So this was a pop quiz which was related to ionic and covalent structures. In the first one, we have to complete a dot and cross diagram to show the electron arrangement if in magnesium chloride. So first, what is the structure of magnesium electronic configuration? It is 282. So first I will draw the atoms, like the magnesium is first shell it is having 2, the second shell it is having 8, and the third shell it is having 2. And for chlorine, the electronic configuration, that is 2, 8, and 7. So first shell it is having 2, second shell 8, and the third shell it is having 7 electrons. So 1, 2, 3, 4, 5, 6, and 7. Now what happened? Magnesium, as we know, for an ionic bond, it's a transfer of electron from metal to non-metal. The metal tend to lose all the valence shell electrons. So first magnesium loses this first electron to chlorine, and the magnesium loses the second electron to the second chlorine. So 7 already belongs to chlorine, and 1 it took from magnesium. Each chlorine atom take 1 electron from magnesium. So as a result, these 2 electrons are being lost. So what will be the charge? Because the magnesium is losing 2 electrons. So when magnesium is losing 2 electrons, what should be the charge of magnesium? So it will be +2. And each chlorine gains 1 electron, so the charge will be -1. And this is a ionic structure of magnesium chloride. And it's up to you. Like example, if you draw the third shell empty, that's fine. If you remove this shell, that's also fine. So both ways it is correct, but the idea is that the magnesium should lose 2 electrons and each chlorine gains 1 electron. Then we have to draw a dot and cross diagram for carbon dioxide. As we know, carbon dioxide contains oxygen and carbon. So oxygen, first we check the group number. So which group oxygen belongs to? What's the group number of oxygen? Yeah, that's right. So oxygen belongs to group 6. So if it belongs to group 6, how many electrons it should share? It should share 2 electrons. And how many unshared electrons should be there? So the unshared electrons will be 4. So if oxygen share 2, the carbon will share 2 from that side. Oxygen share 2, carbon share 2 from that side. And carbon, as it belongs to group 4, so group belongs to group 4 will share 4 electron and unshared will be 0. So the sharing is done for carbon. For oxygen, unshared electrons we have to draw. So 1, 2, 3, 4 and 1, 2, 3, 4. So this is a covalent structure of carbon dioxide, which is also known as CO2. The diagram shows a structure of hydrogen molecule, draw an electron arrangement. So here a single line represents a pair of electrons. So we have nitrogen, hydrogen, hydrogen. Now there's a single line between nitrogen and hydrogen, so there must be a pair of electron between them. Then another single line is there, so means there must be a pair of electron. This also represented by a single line, so pair of electrons, and this also a pair of electrons. Between the two nitrogen, also they have a single line, so means there will be a pair of electron between. But nitrogen, when we check the nitrogen, nitrogen belongs to group 5. So if element belongs to group 5, to complete an octet, it share 3 electrons. Out of 5, it share 3, so unshared will be 2. So it's important we draw the 2 unshared electrons for nitrogen. So each nitrogen will have 2 unshared electrons. So you can just and draw a circle. For each hydrogen, there should be 2 electrons in the circle. And for each nitrogen, there must be 8 electrons. So this is a dot and cross diagram for the hydrogen molecule, which is N2H4. Is it clear? This one, any doubt? So moving on to the next question. We have to draw dot and cross diagram to show the arrangement of outer shell electrons in nitrosyl chloride. So there are two lines, so means two electron pairs should be there between them. And there's a single line between nitrogen and chlorine, so there will be a pair of electron only. So double bond, so two pairs, single bond, a single pair will be there. Then unshared electron on oxygen, oxygen belongs to group 6. So how many unshared electrons I should draw for oxygen? If it belongs to group 6, so belongs to group 6, it shared 2 and unshared will be 4. So 1, 2, 3, 4. And same way, nitrogen belongs to group 5. So group 5 shared 3, so unshared will be 2. And chlorine belongs to group 7. So group 7 shares 1, so unshared will be 6. So this is the structure of nitrosyl chloride. Next is NF3. We have to draw the structure arrangement in the molecule of nitrogen trifluoride. So nitrogen, we check the group. Nitrogen belongs to group 5. So if element belongs to group 5, how many electrons it should share? Belongs to group 5. How many electrons it should share? It should share 3 electrons. So it should share 3 electrons. And how many unshared electrons will be there? So there will be 2 unshared electrons. And fluorine, it belongs to group 7. As it belongs to group 7, how many electrons the fluorine should share? The number of electrons. You can use your mic chat. So it share 1 electron. And how many unshared electrons will be there? So the remaining 6 unshared electrons. No, it's not necessary to mention the group number, share and unshared. This is for you. This part, like in exam, is for you. That is for your assistance. But if you directly know that, like looking in the periodic table as an exam, you will have the periodic table. You just check the periodic table and you work out how many it should share. That's fine. Writing this group number is not important. It's not having any marks. It's just for understanding, like you understand this, that how many electrons I should draw. So fluorine share 1, nitrogen share 1, fluorine share 1, nitrogen share 1, fluorine shares 1, nitrogen share 1. Unshared on nitrogen will be 2 and unshared on the fluorine will be 6. And you have to draw for each of them. So nitrogen trifluoride, this is the structure of nitrogen trifluoride. Then in question 6, complete a diagram to show ions present in sodium as a user positive for sodium and negative for chloride ion. So this is a lattice, which is a regular arrangement of oppositely charged ions. So if we have a positive, then there will be negative, negative, then positive, positive, then negative. And same way, if this is positive, this will be negative, Negative, it will be positive, positive, negative, negative, positive. So oppositely charged ions, when they are arranged in a regular pattern or a manner, what we call that as a lattice. So this is an ionic lattice of sodium chloride. In question 7, fluorine exists as a diatomic molecule. Complete dot and cross diagram to show the electron arrangement in a molecule of a fluorine. So as we know, fluorine belongs to group 7 shares 1. So if this fluorine shares 1, the other will also share 1. And unshared will be 6. Because it's a dot and cross diagram, so one common mistake from students, like they use the same symbol. Maybe some student both electrons for both fluorine atom, you use dot, or maybe some use both crosses. So that's wrong. One you have to use a dot, another one is cross. Even though they are identical atoms, but this is the dot and cross diagram. So we have to represent one type of electrons, one atom electrons by dot, another one is by cross. Next, complete the dot and cross diagram to show electron arrangement in a molecule of PCl3. So best thing is you check the group number. So phosphorus belongs to group 5. As it belongs to group 5, how many electrons it should share? Group 5, how many electrons it should share? Group 5 shares 3. Okay. So group 5 shares 3 and unshared will be 2. And chlorine belongs to group 7. As it belongs to group 7, how many electrons it should share? It should share 1 and unshared will be 6. So chlorine share 1, phosphorus share 1, chlorine share 1, phosphorus share 1. And unshared electron on chlorine must be 7. Oh, sorry, 6. As it belongs to group 7, so 6 unshared electrons will be there. And phosphorus belongs to group 5, so group 5 shares 3 and unshared will be 2. So this is a structure dot and cross diagram for phosphorus trichloride PCl3 molecule. Magnesium and oxygen is, magnesium oxide is formed when magnesium burns in oxygen. Complete a dot and cross diagram. So first we draw the structure for an atom. Magnesium configuration is 2, 8, 2 and oxygen configuration is 2, 6. So first shell 2 electrons, second shell 8 and the third shell 2 electrons. So it is 2, 8 and 2. For oxygen, first shell 2 electrons, the second shell it has 6 electrons. Now what happens, as we know, in an ionic bond, it's a transfer of electron from metal to non-metal. Metal tend to lose electron where non-metal has a tendency to gain electron. And metal will lose all the valence shell, the last shell electron, and non-metal will gain to complete octet. So these 2 electrons from the last shell of a magnesium are transferred to oxygen. Once a transfer is complete, you don't have to show these electrons with magnesium as it is being lost. So the last shell become empty for magnesium. And what is the charge? Because it lost 2 electrons. So charge will be +2. And oxygen gains 2 electrons. So the charge will be -2 or 2 minus. In ionic bonding, it's important that you represent the electrons correctly, like drawing the and writing the charge as well. Is it clear? This one, the magnesium oxide dot and cross diagram. Next is structural formula of ethanol is shown. You just have to complete a dot and cross diagram to show the electrons arrangement in a molecule of ethanol. So a single line represent a pair of electrons and double line represent 2 pairs are there. So between, like, we can start with any, between carbon and hydrogen, there is a single bond. So if there is a single bond between them, so if hydrogen share one, carbon will share one. Hydrogen share one, carbon shares one. This also a single bond. So single bond means there will be a pair of electron between them. Between the two carbon atoms also there is a single line, so means there will be a pair of electron between them. But between the second carbon and the oxygen, there's a double bond. So means there should be two pairs. So if this is carbon electron, oxygen, carbon electron, oxygen. And here's a single line, so carbon and hydrogen. Now, carbon, as we know, it belongs to group 4, so it's share 4 and unshared is 0. Hydrogen share 1 and unshared is 0. But oxygen, there must be unshared electrons as it belongs to group 6. So element belongs to group 6, it will share 2 and unshared will be 4. So 4 unshared electrons on oxygen you have to draw as well. Is it clear, the structure of ethanol? Any doubt in this?
Sir?
Yes.
Sir, what does the double bond mean?
C double bond O, this one?
Yes.
So what is the meaning of C double bonded with O? It means that there are 4 electrons between carbon and oxygen. If we have, like example, if there is a single line between carbon and oxygen, it means that there is a pair of electron or 2 electrons are there between them. If we have a double bond like C double bonded with O, what does it mean? It means there should be 2 pairs or 4 electrons between carbon and oxygen. So if there is a carbon, this is the electron of carbon, then cross is representing electron of oxygen. Same thing, if this is an electron of carbon, cross is representing the electron of oxygen. So if there is a double bond, we have to show 4 electrons between them. If there is a single bond, we have to show 2 electrons between them, or we can say a pair of electrons. So this C double bonded with O means 4 electrons are there between carbon and oxygen. Is it clear?
Yes, thank you.
Same way, as you can see, a molecule of ethanoic acid is there. So some places you can see a single line, some places you see a double line. So what does it mean? If there is a single line, what it shows, how many electrons should be there? 2 electrons. So carbon and hydrogen. This also a single line, carbon and hydrogen, 2 electrons. This also single line, carbon and hydrogen, 2 electrons between them. Between the 2 carbon atoms, a single line, so means a pair of electrons or 2 electrons will be there. But here with carbon and oxygen, again, double bond, double covalent bond means 4 electrons should be there between them. So if electron of a carbon we are representing by a dot, electron of oxygen by cross. Same thing, electron of a carbon by dot and electron of oxygen by cross. So means C double bonded with O or 4 electrons. Same way here, in this one, like this is a double bond, but this is a single bond, CO. So if there's a single bond, we represent by a pair of electron or 2 electrons between them. And oxygen and hydrogen, again, there's a single bond. So we represent by a pair of electron. Now, the next thing is drawing the unpaired electrons. How to know the unpaired electron? To check the unpaired electron, you have to check the group. Like if element belongs to group 4 and a non-metal can belongs to group 5, it can belongs to group 6 or it can belongs to group 7. So with reference to the group number, you will know how many it will share. Group share 4, group 5 shares 3, group 6 share 2, group 7 shares 1. And how many unshared will be there? 0 for group 4, 2 for group 5, 4 for group 6, and 6 for group 7. So unshared electrons are always in even number, 0, 2, 4, 6. So oxygen shares 2. If this oxygen share 2, so how many unshared electrons will be there? 4. So we have to draw 4 unshared electrons. on each oxygen. So this is a structure of ethanoic acid, which is having between carbon and hydrogen, there are single bonds. So means a pair of electron. But between the other oxygen and carbon and oxygen, there is a double bond, or means 4 electrons will be there between them. These 4 electrons. Is it clear, this one? So this is a structure of ethanoic acid. Then we have to draw a dot and cross diagram for hydrogen sulfide, H2S. So we check hydrogen always share 1 and unshared will be 0. But we check a group for sulfur. Sulfur belongs to group 6. So if it belongs to group 6, it will share 2 electron and unshared will be 4. So if hydrogen share 1, sulfur share 1, hydrogen shares 1, sulfur share 1. And unshared electron on the sulfur will be 4. So this is a dot and cross diagram for hydrogen sulfide or H2S. Next, we have to draw the structure of ethanol. It's a similar what we did. So if there is a single line, means a pair of electron. A single line means a pair of electron. A single line means a pair of electron. Again, a single line means a pair of electron. Single line between carbon and hydrogen, so means a pair of electron. But there is a double line between carbon and oxygen, so means 2 pairs should be there, or 4 electrons. And then we draw unshared electron because oxygen belongs to group 6. So group 6 will have 4 unshared electrons. So how you distinguish a double bond with a single bond? When there's a double bond, it means there are 4 electrons between the atoms. If there is a single bond, like carbon and hydrogen have a single bond, means there are 2 electrons between the atoms. Is it clear, the structure? Any doubt in this? The next we have to draw ionic structure of lithium nitride. Lithium nitride means lithium with nitrogen. So if you want to draw a lithium nitride, an ionic compound, first and draw a diagram to show its formula and the charges on the ions and arrangement of valency electrons around the negative ion. So only for negative ions, how the electrons are arranged, the valence shell we have to draw. So nitrogen belongs, and lithium, first we identify it's an ionic compound. Ionic compound means it consists of metal and a non-metal or formed by transfer of electron. So first we have lithium Li. If you draw one lithium, the electronic configuration for the lithium first shell, it has 2 electrons, and the second shell, it has 1 electron. For nitrogen, we just need a valency electrons arrangement, like means the last shell electron. So nitrogen configuration is 2, 5, but we just need the last shell. So we draw the last shell electron. Valency electrons means electrons in the last shell. When they say valency electrons means electrons in the last shell. So how many electrons are there in the last shell, that we have to draw. How we know this? We can know by it's a group number. The group number shows the valency electron. Like element belongs to group 1 means it has 1 electron in the outermost shell. Element belongs to group 2, it has 2 electrons. Same way, group 3, 3 electron, group 4, 4 electron, group 5, 5 electron. So nitrogen belongs to group 5, so it is having 5 electrons. Now what happened in ionic bonding? The metal has a tendency to lose electron, non-metal gain. So lithium will lose electron, nitrogen gain. So the metal has a tendency to lose all the valence shell electrons. So this lithium lost one electron, and nitrogen gain one, but it's not stable. Why it is not stable? Because to be stable, it must have 8 electrons in the outermost shell. So 1, 2, 3, 4, 5, 6 are there. So it's not stable. So there must be another lithium around it. There should be another lithium atom around to give another electron. So electron will transfer from lithium to this. Again, nitrogen is not stable. Why it is not stable? Because still it has 7 electrons in the outermost shell. It must have 8 electrons. Then we draw another lithium. So nitrogen, again it loses one and the lithium will gain, lithium will lose electron, nitrogen will gain. So nitrogen gain 3 electron. If nitrogen gain 3 electron, what should be the charge on the nitrogen? It should be 3 minus or minus 3. So nitrogen is a negative ion. And because lithium is losing electrons, so it should be a positive ion. Negative ion means it's an ion which gain electron or it has extra electrons than proton. And the positive ion means it has more protons than electrons. So if an atom lose electron, turn into a positive ion, atom gain electron, turn into negative ion. So this is a structure of lithium nitride, and the formula of this compound, lithium nitride, lithium, there are 3 lithium, so Li3 and 1 nitrogen, so N will be there. So Li3N is lithium nitride. Is it clear, the structure? The ionic structure of lithium nitride? Then in question 15, draw the structural formula of carbonyl chloride and use circle to represent the electron of carbon, use cross to represent the electrons of chlorine, and use dot to represent the electrons of oxygen. So you have to first draw the atoms. We have carbon, we have oxygen, we have chlorine, and another chlorine. Now, as you can see, a single line is there between carbon and chlorine. So means there should be 2 electrons or a pair of electrons. So, and carbon electron we represent by a circle and the chlorine is by cross. Same way, there's another single line between carbon and chlorine. So carbon electron we represent by a circle and the chlorine electron we represent by cross. And then there's a double bond between carbon and oxygen. So means there must be 4 electrons between them. Carbon and oxygen. So carbon we represent by a circle and oxygen we represent by a dot. Then carbon by circle and oxygen by dot. Because double bond is there, so means there must be 4 electrons or 2 pairs of electrons. Then unshared electron, you have how to know unshared electron? You have to check the group number for each. Like chlorine belongs to group 7. If element belongs to group 7, its share 1 and unshared will be 6. Oxygen belongs to group 6, share 2 and unshared will be 4. And carbon belongs to group 4, so its share 4 and unshared will be 0. So for chlorine, we have to draw 6 unshared electrons. So 1, 2, 3, 4, 5, 6. Same thing, 1, 2, 3, 4, 5, 6. Carbon does not have any unshared, and oxygen, there should be 4 unshared. So 1, 2, 3, 4. So this is a structure of carbonyl chloride, in which is having a double bond between carbon and oxygen and a single bond between carbon and chlorine. Is it clear, this one? So this was a pop quiz which was related to topic ionic and covalent structures. And I have shared another pop quiz the morning today, which is related to bonding and structure as well. So solve and submit that as well.